So tonight we're going to be looking at advanced stair and railing construction. So we're going to build on what was taught in the intro course and fill in some of the more advanced components of stairs and railings. Okay, so in the Stair Tool set, when you start up the Stair Tool set, you are able to go into two different creation modes for building stairs. Now, it's not really obvious, but this button here allows you to go into sort of the old school Revit stair mode where you're using green lines for the edges of the stairs and black lines to draw the risers. So those are your two different options. The top tools that you see up here are the component-based stairs. So component stairs, if we look at the points on the bottom of page 1, we have the run, the landing, and the supports. So stairs are built of those three pieces, provided that you guys use these top sets of tools. Now, if any of you do residential construction and you use winders, you can't use these two winder tools because they're not compatible with any building code in Canada. And frankly, they look terrifying. Like, that just screams lawyer up written all over it, right? Because that does not look like a Canada compliant stair, so don't even bother. So we'll look at both modes here. So the component stairs and then the sketch based stairs. Now, first of all here with the component stair, so when you fire up the stair command, Revit by default kicks you into creating the runs. So again, runs are one of the three parts of a stairs construction. So when we're looking at our stairs properties here, remember that your component stairs break down into three general different kinds of stairs. So when you start up the stair command, now you look here that you can see the three different kinds of stairs. Assembled, which is wood frame or steel, cast in place, and precast. Both of these are concrete stairs. So what I'm going to do here is I'm just going to draw three quick stairs in succession, one drawn from each of these. So here's our out of the box assembled stair, and I'll just draw a straight run for it. Actually, I'll do risers, or a landing rather. So there's the assembled stair. So the next one here is going to be the cast in place. And I'm not too worried about exactly how I draw them, because really what I want to demonstrate is how they are modeled a little bit differently. This is interesting. I'm not sure why it's doing this, but with the precast stair, you'll see here that it didn't have the end with riser checked. I'll mention that in a moment. Mostly what I want to focus on here is how Revit builds these stairs differently. Okay. Just going to turn on shading here. Now, so here's the assembled stair. So assembled stairs are built of a run. So that's the part in the middle there between the stringers. So you have your run, your supports on either side of the stair if you need them, and then the landing, which is kind of similarly constructed to the run itself. So that is your assembled stair, and like I said, that's for wood frame and steel. Now the next stair that we're looking at here, this is the monolithic stair. So that's the cast in place stair here. So Revit's calling it the monolithic stair, but you could call it, you know, concrete. The name doesn't matter. What matters is that it is the cast in place stair of the three different kinds of component stairs. And so what you get with this particular kind of stair is you get, as you can see here, a monolithic stair. So you've got your rise, your run, and your landing are all made of the same material. So you don't have a separate material for your riser versus your tread, whereas on the assembled stair here we could have a separate material for the tread and then another material for the riser, and then materials, different materials yet again for the stringers. With the monolithic stair, it's obviously just all one material. The precast stair, what it's supposed to do here, and it didn't do it in this case, probably because I did a switchback stair, it creates a notch so that each stair flight is supported by the next component up. So let me draw this again. Hopefully it will cooperate. Okay. So here you can see how the precast stair works. It builds the lower flight, puts in a notch, and then we have our upper flight, and it goes up and ends in a notch as well. So the idea being that you get essentially is the general shape of a precast stair. Now, if you're hoping to do shop drawings for precast stairs using Revit's tool set, I wouldn't hold to it. You probably aren't going to be able to control the dimensions of it the way that you want. And for most of us in the architecture industry, that's not really the object. It's not really our scope of work to make those shop drawings for the stairs. It's mostly for code compliance and the general arrangement of the stairs so that they can be constructed. So the bottom line is, with this stair tool, if we're not switching to sketch mode and drawing stairs the way that they were done in Revit prior to the creation of these component stairs, which have been around for about 5 years. So you've got the three different kinds of stairs: assembled, cast in place, and precast. So let's have a quick look at the sketch tool system. So with this one, you draw the sides of the stairs using boundary lines, and then you draw the risers yourself. So you have to draw each riser individually. So if I'm doing a stair here that's 3'4" wide, I use the riser tool and make that riser line 3'4" across, and then you have to copy or draw the rest of the risers yourself. What I'm going to do in this case is I'll select this one riser and I'll use the copy command, and I will make a few copies of it here. And you'll notice on the drawing area here that Revit's keeping tally of the number of risers that I need. So I need 18 risers total. It's going to keep going here. So I need 18 risers. And so you can either offset, or you could use the array command to build the number of risers that you need for the flight. So alongside each flight of stairs, you need boundaries. So the boundaries go at the edges of the flight, and then if you've got a landing to construct, you draw the boundary lines along the edges of your landings as well. Now, the reason that you might want to switch into the sketch mode is if you're drawing a stair that has an irregular shape, and you know that from the beginning. The component stairs build initially a very regular shape where the flights of each flight of the stair is rectangular in shape. It's easy enough to change their width, but if you do need to make an oddball shape, so for instance here, if I needed to make my stair follow that kind of a shape, I would just start with the sketch-based stairs. We'll talk about the process of editing the shape of one of our component stairs in a second. So again, with this, I'm just putting in my risers here, drawing them in manually, and making as many as I need. So I can see Revit's counting me down here, 3 remaining, 2 remaining, 1 remaining, done. So you just have to put those boundaries along each side of the stair. So that's the rule. And really what the idea of the sketch-based stair is to allow you to build a stair that's got an oddball shape. What's a little weird about the sketch mode stairs is that as long as this boundary line here is at an implied intersection with the extension of this line, Revit doesn't care. And if the riser line happens to go beyond, again, Revit doesn't care. So we're not done here. There's one more thing that we have to put in. It's the stair path. And just like we have separate lines for the boundaries along the flights, and then along the landing, and then along the next flight, we have to have separate stair path lines, and generally we draw them through the center of our path. That's it. So copy your risers, draw boundaries along the edges, and then put the stair path line down the middle of the stair. And you might be like, well, that's kind of messy looking. Revit's going to be happy with it. So there's all of our risers created, and we're finished. So Revit will generate the stair here in a few moments. Now, some rules about the boundaries. So here I'm just digging in here and editing each layer. So let me just draw a new stair here with the sketch mode again. So going to stair, and I'm going to use the assembled stair here. So I'm building a wood frame stair. So before I start drawing my sketch for this stair, I'm already choosing to go with the assembled stair. So what I want to demonstrate here is doing it wrong. So I'm just offsetting a few risers here to get myself started. And then I'm just going to copy them because that's even faster to get it done. So what's that? That's 9. So okay, so here's what you should not do. You shouldn't run your boundary from one end to the other as a single boundary line. Revit needs you to create breaks between your flight and then your landing and the next flight. Now, what this green line really represents is the stringer in your stair. So in your sketch stairs, the green line, the boundary, especially if you're using the assembled stair, builds the stringer or the support along the side of the stair. So if I finish now, you folks will have a look at what this is going to do. Revit's going to give me a little, well, it didn't give me a warning, but we'll see what it, there you can see, the folks can see what happens. So just straight shot the stringer from the top to the bottom. So that's why we need to create those breaks in the boundary lines. So right here, that boundary line, all I need to do is use the split tool and just split it at that last riser on both sides, and that will allow the stringer to articulate. So it'll come up, follow the angle of the first flight, go flat for the landing, and then up the other side. So there you go. So once that's done, you folks will see that the stair stringers follow that path. Now, visually speaking, you can't tell once a stair is finished whether you built it with the sketch mode or built it with the component mode. They both look the same from the outside. But again, the point of these sketch stairs is just to allow you to build a custom shape. So let's look at parts of component stairs. Bottom of page 1. So again, with our assembled stairs, we have runs, landings, and supports. So let's just look at the type properties dialog here for the out-of-the-box assembled stair in the architectural template. So if you folks are wanting to follow along, just make sure that when you start a new project, Control N, that you choose the architectural template, because that's what I will be referring to tonight. So I'm deleting all my other stairs and just leaving the component stair visible here, the so-called assembled stair. Now, for things like the rise and run of the stair, that is determined in the stairs type properties. So for its code compliance, if you're doing a part 3 exit stair where your maximum rise is 180 millimeters and your maximum or your minimum run is I think it's 230 millimeters. We should talk about how we set that up. So what I'm going to do here is I'm going to turn this into a part 9 stair. So we'll just talk about the code compliance path that you would have to have for a stair. So I'm going to take the out of the box 7-inch riser, 11-inch tread, and I'm going to rename it part 9 stair. So if you folks want to follow along, you'll be able to see the process by which you can create a stair that's compatible or compliant with part 9. We'll make a part 3 stair in a second. So we're still on the bottom of page 1 of our notes here, and we're just going to walk through the process here. So this is the type properties. A lot of this stuff is fairly straightforward. One thing that you can add to your notes tonight, when we're talking about the type properties of your stair and ensuring code compliance, when Revit talks about the minimum tread depth, what this really means here is the stair's nominal run. See, what Revit does here is this is the tread. And then if you specify a nosing, Revit will add one on. And if you do have a nosing, Revit isn't going to talk about it here. So when it says minimum tread depth here, what that really means is your run. All right, so here's your tread, and here's a situation if we do not have a nosing. Right, so we calculate our run off the front of the stair. So that's our run. So Revit will call that the minimum tread depth. But if we have a stair where we specify a nosing, Revit ignores the nosing when it's talking about the tread depth. So that tread depth here, like normally you and I would call this distance here the full depth of the tread. We'd call that the tread depth. That's not what Revit does. Revit does exactly the same thing. Revit calls that here, I'll put it in quotes, the tread depth according to Revit. So it's just your nominal run. So keep that in mind. So with the rise, everything's cool. It's just the tread that's you got to keep your eyes on here. So that's a good thing to note. So for dealing with part 9, we've got a maximum rise of 200 millimeters. So you can just type that in directly. So you can see I typed in 200 mm to get the max rise allowed in part 9. And then for the tread depth, I think it's 230 millimeters. No, it's 250. That's what it is. They just changed it this last version of the code. 250 mm. Yeah, so you know what? Let's just go check with the building code here. If any of you want the PDF version of the building code, it's freely been handed out by the province of BC. So I've downloaded and organized all the PDFs into their own folders. So you're welcome to have it here. So there's our, all right, 255. Okay. Yeah, so 10 inches. You think the building inspector is going to notice that we're missing 5/128ths of an inch on that tread? 10 inches. So here we've got a part 9 stair. So now when you start using the stair in your project, it's going to be part 9 compliant straight away. Of course, you can put in the 880 millimeters for the minimum width, so 2 foot 10 and change. Might as well just leave it at 3 feet. So that's the minimum width stairs allowed to have under part 9. So now when you draw this thing, we make a new stair here. So now our part 9 stair, we need 16 risers to get from floor to floor. Now when you're using the assembled stair, after you've placed the stair, oh, this wretched thing. I don't know why it's doing this. You folks notice here that it's not, see how it's not ending the last stair with a riser? Sometimes Revit just starts doing this and I have no idea why, and it's absolutely infuriating. And you can't change it before you draw the flight. It just, see, there it is, it did it again. And you can tell because your stairs will be numbered and then the last riser won't have a number on it. And when you click it, you can see the checkbox is unchecked. I don't need 17 risers, and Revit's telling me that now. I've got 16 plus 1, so it's Revit saying, hey, you can get rid of that extra riser just by clicking on the round dot at the end and pulling it back 1 riser. Don't know why Revit gets into this mode. Now, after the stairs have been placed, you can click on each flight, and you folks can see that there is a temporary dimension that appears on the flight so that you can change its width. So if you want it to be, 3'2", go ahead. Just be aware that when you do this, Revit only changes the width of that one flight. It doesn't change the width of the landing, which would be required now because my stair is 3'2". So my landing must be at least 3'2". So you can click on each piece, the landing that gets created, and then the other flight, and you can change their width values as well. The temporary dimensions will appear so that you can make those changes. So there's our part 9 stair. Now, if we go look at part 3 here, so I'll pull up part 3. What's that? you have to come and get it from me. So if you want it, come and get it. If it's not on the network here, you can come and get it from me. So we're allowed to freely distribute it now, where we were not allowed to before. I just got to go down to my stairs here. Just want to get the, yeah, you can get it right online. You can get it right, go to the BC Codes website and download it. It's free. It used to be $300 or $400 for the, yeah, pretty wild. So yeah, just this summer, the BC Codes branch, because the National Building Council stopped making the provinces pay for the building code. So as a result, the province, as soon as that happened, they said, okay, well now it's free for everyone, which is fantastic. So here we go. So there's our minimum run of 280 and our maximum rise of 180. So let's go back to Revit here. So we can just start with our existing Part 9 stair here and duplicate its type and call it a Part 3 stair. Right? So just edit its type and duplicate it, and we'll call this a Part 3 stair. And we'll just punch in the numbers that are required to make this compliant with Part 3. So we have a maximum rise of 180 mils and a minimum run of 280. So for our Part 3 stair here, our maximum riser height is 180 mm. And our minimum tread depth, and again remember Revit means the run here, so whether you've got a nosing or not, it doesn't matter. When Revit says minimum tread depth, it actually means run. 280 mm. So again, there's our 11 inches. Don't think the building inspector is going to notice those 3 128ths of an inch that I'm going to remove here just to make my steps 11 inches. And so now, if you don't know if you folks noticed, before we started, we could get 16 risers to get us from level 1 to level 2, and now because of the reduced riser count, or the reduced rise that we're allowed, we need one more rise, so we're up to 17. So here, we can just draw that across the screen. And Revit is stuck in its ways here. It's decided to not end with my riser here, so I can get rid of it. So there's our Part 3 stair. Now, a few things just to remind you about here. This is something that we'll be talking about here. I'll just mention it's on the bottom of page 3, just so that you remember that this is how you edit the number of risers in a flight when you have a switchback stair, or when you have a stair that has a landing in it. So we're going to talk about the dot handle and the triangle handle. This is on bottom of page 3. So with each flight of stairs, when you click on them, you have a dot handle and a triangle handle. So the dot handle on the top flight is used to add or remove risers to the entire stair. So if you did need to have 17 risers in your stair, you do it by editing the top flight and dragging that dot to create or remove risers from the flight as needed. You cannot do it from the bottom of the stair. If you try to do it at the bottom of the stair, let's say I drag this up, what this is going to do, look at this, my first riser is labeled with a 2. Because now this first riser is 16 inches off the ground. So yeah, don't do that. You want your bottom riser just to stay put. You'll see the round dot. Don't drag that dot on the bottom of the stair. I don't even know why it's there, because nothing good can come out of dragging that round dot at the bottom of the stair. Just don't touch it. Now, if you want to add or remove risers from one flight or the other, you can drag the triangular handle as needed to move risers from one flight or the other. So here in my straight run stair, if I click either flight and drag that triangular handle, I can add or remove risers from that flight. Same with my switchback stair here. So I can just double click on a stair to edit it. So there's my stair. And so if I use a triangular handle, I can add or remove risers from that flight, and it puts it over to the other stair. Now, on page 2, I am glad that I mentioned the about 3/4 of the way down the page about the run component tool can have a riser at the beginning and the end of the flight. That's the check boxes when you check on the risers here. When Revit gets into the bad and annoying habit of when you're creating stairs, and it will sometimes uncheck this end with riser checkbox, especially if you're using the precast stairs. It seems like you start using the precast stairs and Revit starts messing around with this checkbox. And the only way that you can sort it out is to quit Revit and come back in. So I'm going to do that here. So I'm just quitting Revit and I'll come back into it here. Now while we're waiting here, we'll just talk about the arrangement of stairs and the different parts of them in the project browser. So I want you folks to go down into the project browser and look inside the stairs folder inside the project browser and expand it. You're going to see the list that's at the top of page 2. Oh boy. I restarted Revit and it's still not fixing that end with riser nonsense there. Oy. Okay. So looking inside the stairs folder in the project browser, so in boldface it shows the main sort of most important folders that are inside the stairs folder. So inside the assembled stair folder, when you folks expand it, it will show you all of the different kinds of assembled stair types that you have defined so far in the project. So you got your part 3 stair and the part 9 stair that we've been talking about. And then the other folders are for our precast and monolithic concrete stairs. And we'll talk about the other parts of the project browser's organization in a few minutes. Okay, so back to page 3 to the top of it here. So just with regards to the landings. So when you construct more than one flight inside the stair, Revit automatically makes a landing that connects the two of them together. So if I delete my upper flight here, because I need to rebuild it, I can delete the landing as well. And now when I go to use the run tool and put in my revised upper flight, Revit tries to create a landing that suits the next flight of stairs that I'm drawing, which is handy. So Revit automatically creates this landing. Now the construction of the landing, if we look at its properties, what the landing just does is it looks at the construction of the run and essentially makes it the same, makes it to match. And we'll talk about the construction of the run in a few minutes. Now, let's move over to page 4 here. We're going to talk about the supports. And we're going to talk about them in more detail here. And we're going to talk about how you can use profiles, like a C-channel steel profile or an HSS tube, to build the stringers of a steel stair. So what I'm going to do here, if you folks have made the part 3 stair, what I'm going to do is I'm going to, in the project browser, I'm going to right click on it and duplicate it so I can make a new stair type that's going to be steel. And in particular, we're going to use an HSS tube. In a few moments, you folks will have an exercise where you add a stringer using a C-channel. But in this case, we're going to use an HSS tube because there's a specific step that you need to go through to make this possible. So, duplicating the part 3 stair, and now I'm going to rename it. And we're going to do this by 4x10 HSS. So this is going to be a stair that's compliant with the code with respect to part 3, but the stringers will be constructed of 4x10 HSS tubes. So now you can actually just double click on the part 3 stair in the project browser, and that allows you to edit this stair's construction without actually having to use the Stair Tool. So what we want to do here, we'll come back and talk about the run after the break. We're going to talk about our stringers. Now, if you remember from the intro course, if you're using stringers at the sides of your stair, you can have closed supports or open supports at the sides of your stair. Okay, so if the supports at the side of the stair basically hide the steps when you're looking at the stair from the side, this is called a stringer as far as Revit is concerned. If, though, when you're looking at the side of the stair and you can see the tops of the treads, so more of a wood frame scenario, Revit calls this a carriage. Now, I'm not convinced that anybody in the construction industry around here would make this distinction between the supports. No idea. But that's what Revit calls them. Now, with the carriages, they really can only be based on a rectangular shape only. So what I mean by that is taking an original, like a 2x12 shape and then just notching it to suit. So you can only have a rectangular profile for this. For a stringer though, if you want to have a channel shape for the side of the stringer, totally possible. So with the stringer, we can use a profile. And we'll see that in a few seconds. So stringers can use profiles. Carriages can only be rectangular. Okay, so first of all here, we'll look at the carriage option. So we're going to switch on, just for the time being here, we'll switch our part 3 stair here. I'm just going to look at the carriage option for a second. So this is the notched style stair. Out of the box, the software defines the carriage as this 2-inch width. And in fact, if I were to go down here into the carriage folder, we would see this carriage 2-inch width in that folder. So once you specified whether it's carriage or stringer, underneath here it'll show all the different carriages or all the different stringers, depending which kind of support you choose. Now, if you choose carriage, it shows you the carriage types defined in the project so far, which is only one. Then you go over to the right hand side, so you can see my cursor is flashing in the right support type field here. Go over to the right hand side and you'll see a little button with 3 tiny little black dots. If you click this button, it spawns up a dialog box right in front of the one that we're looking at. So there it is, there's our new dialog box, there's the one that's in the background there. This is it here, carriage, 2-inch width. On site, if you were to go on site, look at a stringer, it's probably going to be a 2x12. So the propeller heads at the Revit factory, they're right, 2x12, but they're wrong because it's actually 1.5 inches by 11.25 inches. Right, a real 2x12 is 1.5 inches by 11.25 inches. So, yeah, you don't get lumber like this unless you get it custom milled at a sawmill somewhere. So I'm going to rename this. Instead of calling it carriage 2-inch width, I'm going to call it carriage 2x12. So we're very specific now. We know this is a 2x12 carriage that's going to be placed at the side of the stair. Now you'll notice some other properties that are in here. We have the structural depth on the landing, 2.5 inches, and structural depth on the landing. What these two numbers represent. So right here at the thinnest part of the stair, that 2.5 inches is the minimum amount of meat that would be left at the back of your tread between that corner and the underside of the carriage. So 2.5 inches structural depth on run, that represents this dimension here at the back of the stair. And if you cut a section through it, you can see that Revit's maintaining that dimension. The 7 inches on landing, what happens is when your stair comes up and hits a landing here, Revit just simply maintains 7 inches here for the thickness of the structure underneath the sheathing on your landing. Not a big deal there either. So yeah. So as soon as we've made that change here to the carriage name and the carriage definition, I wish I had the stringer folder here expanded. I'm going to do that here. And carriage. Okay. So you folks will notice now that in the carriage folder, it used to say carriage 2-inch, and it doesn't. It says carriage 2x12 now, so that you can see that the changes we've made have really taken place. Now, we're still working on this HSS tube. So the HSS tube is actually, it is going to be a stringer. So for our supports for our HSS stair, both sides have to be in stringer mode. So find right support and switch it from carriage to stringer. So both sides, stringer. Now what we need to do is switch things up so that instead of using this full 2x12 rectangular shape, we can use something else. So here we go. So this spawns up the stringer definition dialog, which looks pretty similar to the carriage definition dialog, but there's a difference. Here we've got a section profile that you won't see in the definition of a carriage. The reason for that is that when you're defining a stair in Revit, so here just looking at plan, you can define supports for the sides of your stair, and you can define intermediate supports that go underneath your treads. So your supports on the sides of the stair, of course, can be carriages or stringers, you know, where the top of the support is actually higher than the walking surface. But you couldn't have a stringer running down the middle of your stair because, of course, you can't walk on it. So you can only have carriages as intermediate supports for your stair. But we're making a steel stair here, so we're going to be making it out of stringers. So carriage style stairs won't allow you to take a C-channel profile and cut it down. It's only your stringers where the shape of the thing isn't being cut, but allows you to do something funkier with the shape of the supports on the side of the stair. Now, out of the box, the architectural template has one steel channel profile loaded already. So let's duplicate this, and we'll call it HSS 4x10. So in a few seconds, you folks will do the business here to use this other profile that's in the stair, the 9x15. So there's already a profile family here. All the profile family is just a black set of 2D lines that defines the outline shape of a 9x15 steel channel. Now, what we're going to have to do here is we're actually going to have to exit out of this dialog box and load in this HSS profile. So for now, folks, just go ahead and hit OK, and hit OK. And so what we need to do is load that HSS profile. Let's get her done. Insert. Insert tab, load family. So in your library, we need to go down to the profiles folder. So once you're inside the profiles folder, we're going to go to framing. Inside the framing folder, choose steel. And now in the steel folder here, we're going to go down to HSS, there we go, not the round structural tubing, but the hollow structural section profile. So we're going to open this up. Okay. Now sometimes you see a dialog like this that opens up when you load a family. This is called a type catalog, and this will show up when you're loading a family into Revit if in the same folder as the family that you just opened, there's a text file. And the text file has all these different sizes and all these different dimensions for the family. So some families in Revit, they come with this so-called type catalog. It's just a text file. And if Revit sees that text file that has the same name as the family, it spawns up this dialog box. So we want to go down and find HSS 10x4, and I'll use the 10x4 by, let's use the 1/2 inch one here. 10x4 by 1/2 inch. So when you load a profile family into your project, you don't see it. Nothing seems to happen. But what has happened is that in the profiles directory, there it is there. So that's the family we just loaded in, the HSS hollow structural section. And inside it, you'll see that size that we just pulled in. So profiles, as you folks probably know, are used by handrails. They're used by your fascia. on the outside of your roof. They're used by gutters and all kinds of different things. So this HSS tube here now, we're going to use that in our stair. So let's go back and find our assembled stair here and double click the 4x10 HSS stair. So what we're going to do is we're going to further define this HSS 4x10 stringer. So here I've started with this HSS, and I'm going to hit the button here to go back into this dialog box. So here's where we were moments ago. We just needed to load in that HSS profile, which as you can see is down at the bottom of the project browser there on my screen. So we're not going to use the C shape this time. We're going to switch to the HSS. Now you'll see the HSS isn't in here. So now we're going to talk about why. Why can't we load that HSS in here? We've got the C channel in here, but the HSS won't allow it. So let's go back out to the project browser here. So what we're going to do, folks, is we're going to right click on our, I'm going to go up to our profiles here. We're going to right click on this family, the HSS hollow structural section profile. Now this isn't in the notes, this is just something that I wanted to do with you folks. For those of you who do steel stairs and you want to include a something other than the C-channel profile, a couple steps that you need to be able to deal with. So I'm going to right click in the profiles folder, I'm going to right click on the HSS hollow structural section here and edit the family. So this is a profile family. It just defines the shape of the tube. It's a 2D series of lines, and in fact there's some categories that are turned off here. So I went into the visibility dialog box here and I'm turning on the annotation categories. And there's these are just 2D lines. That's all it is. So there's some length parameters here so that you can change the size of the shape. This isn't the problem. There's nothing wrong here with why we can't load it into our stair. The problem is up here in the family category dialog. Now actually looking at this, there's no reason why it shouldn't have worked. But I'll talk about it anyway. So here, when you're looking at profiles and loading them into your project, so you've got a profile that you want to use for a fascia or a profile you want to use for your railing. Profile usage. So this tells Revit what the purpose of this profile is for. If it says generic, it means you can use it for anything. Now you'll notice that when you click in the generic row here, you can specify that this thing can be used as a fascia, a gutter, or a mullion, or whatever. Now, if I were to use this as a stair support, now what would happen is I couldn't use it for anything else in my project. So if the profile usage says generic in here, you can use this profile for anything. You could use it for a stair tread, you could use it for a fascia, you could use it for a handrail, whatever you want. So typically I just leave my profile usage as generic, and then anything in Revit can use it. And it was set to generic. So why couldn't this profile be used on our stairs? And the answer is that when Revit allows you to build a stair profile along the sides of the stair, it can't be hollow. We have one loop around the outside here and another loop around the inside. Now I'm just going to undo this step here so that I can just not see those dimensions, right? We have two loops. So a long time ago, I learned that if I want to use one of these structural profiles in Revit, I have to get rid of the inner loop so it'll no longer be hollow. So yes, when you cut a section through it, it's not going to look like a hollow tube. You'll have to draw that in 2D in your stair sections. C'est la vie. Frankly, you're going to have a detailer who's going to be doing this for you anyway, and the contractor is going to look at your stairs and never notice that that inner loop is there. So it doesn't matter. So what do we got to do? All we have to do is put our cursor over one of these lines on the inside, hit the tab key so they're all highlighted, click, delete. That's it. So now this profile can be used in our stairs. So we just got to load it back into our project. There we go. So now, because we've redefined this family and removed that inner loop, it means that now our stairs are going to be able to deal with it. So now when I go back and double click in my assembled stair folder here under stairs, double click on my part 3 stair 4x10 HSS, and I go back and find my support and find my right support type here. So if you remember before, that HSS Tube wouldn't even show up on the list, and that's because Revit wouldn't let us because it had that extra profile loop in there. Look at that, there it is. So that's the HSS on that side. Now I'm going to put it on the other side here. There. So now this stair will have an HSS tube on both sides. So now I can start up my stair command, and we're going to use this part 3 stair here 4x10 HSS, and I'll just draw it here down at the bottom. I don't know about you folks, I'm still having that terrible problem where Revit is yeah, it's always leaving my end with riser box unchecked. That's super annoying. And I actually don't know why Revit's doing it. Maybe because I've got, do I have any, I'm just gonna check and see if I've got any of those stupid stairs left. I don't think I do. Anyway, so here you go folks, have a look at this. So there's my HSS tube stair. Pretty sweet. It's got the nice radiused edges there, and it works its way up. So if you're doing a steel stair, you can see it even trims off the bottom of the stringer at the floor line. So that is our supports. We'll come back and talk about runs after the break, so we will break until 8 o'clock.